Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Rocket Monday, we're going to talk about Starship Flight 10. So let's dive deep into it. So Flight 10, basically you have to understand the gap between 9 and 10 is huge. The reason is test 9 was not smooth. That puppy happened on 27 May 2025 and it's supposed to do a booster rehearsal landing, and the moment they tried to reignite the engine, it went kaput. It did not went kaboom like it's supposed to, it went kaput. So things went bad, and it happened to much higher altitude. So this was bad. And then Starship also failed to reach where it's supposed to reach, which was a ouch. And the primary two target was there. They wanted to test first, can they reignite the engine in space and shut it down in space. That did not happen. And they wanted to deploy simulate payload, basically dummy payload, to just figure out that the pest dispenser, does it work or not. That failed. Why? Computer detected they were not on the right altitude, and there were some other problems also. Basically, booster also went kaput and the Starship also went kaput. And after that, they were like, okay, let's keep working. That was nothing new because the last 3 launches were not that great. So Starship 36 was being worked on, almost doing a wet dress rehearsal, and then it went kaboom. And this was a very big boom. Let that be very clear. We are looking from a telephoto lens, so it sometimes gives you compression, so you do not understand how huge it is. This is huge. Huge, like miniature nuke kind of huge. There are very few ordnance that will cause that kind of damage. Again, it's not at the force, but the fireball it had. So fundamentally, things happened. Bad things. The last launch was bad, and then this happened. Lot of things had to be stopped, and then they had to rework brick by brick, day by day, to get to next launch. That's supposed to happen on 24 August, but that got scrubbed simply because ground equipment did not contribute. And again, that's normal thing, does happen once in a while. After that, 25th was the next launch date. That they did, but that time weather did not contribute. So anvil cloud was created. Basically, thunderstorm was there. So they're like, can you fly through a thunderstorm? Yes. Should you fly through a thunderstorm? No. So again, it can, and most likely thunderstorm will not cause that much damage because the electric field that would be created because of the Faraday cage effect should be strong enough in case of Starship that it should handle it. It should be able to tank it, or worst case scenario, go kaboom because of it. So, and again, almost all big rockets have got electrocuted once in a while. So it could have survived, but it's better to not risk it. And then 26 August, 5 a.m. morning Indian time, it finally took off. So it was a messy road. Let that be very clear. It was a messy road. So flight finally, after string of 3 bad systems, they had something that worked as expected, meaning the booster launch, it did hot staging and did simulation landing. Now, let that be very clear. The simulation landing does look weird. It's like, why the heck it's hovering? Well, the best explanation I have gotten about that is simply because if they let it land and tip it over, it does go boom, but does not deflate itself properly. So it does not sink. Many times it literally remains there for hours. That becomes a hassle, which is SpaceX hassle. They have to deal with it. And again, apparently there is a story of a Falcon 9 booster that did not sink, and they had Air Force training going on there. Like Air Force is like, can you boom it? So to make sure that they do not require a boom event, they're like, okay, what if we do all the testing but bit higher up, and the fall, the gravitational fall will shift delete the rocket. So that's why the moment it touches the water, it goes boom, it shift deletes the rocket. So they no longer have to worry about floating debris. So that's why it has such a trust fall, so to say. And payload deployment work. This time Starship actually went to, and this is the first time they're actually doing what they're supposed to do. Let that be very clear. A rocket is judged by the payload in the orbit, not reusability. If you are a rocket that is reusable but does not dump anything into orbit, does not matter. So this is a very big, genuine milestone where they're like, okay, we are actually deploying payload dummies. Again, I'm not sure why the heck they did not test the satellite itself, because satellite supposed to be mass produced. So if you're mass producing it, eating 7 to 8 of them or risking 8 or 9 of them should not be a big deal. And again, even a elliptical orbit, shallow orbits would have been far more useful. 30 minutes of real space data is priceless compared to hundreds of hours of testing. So I do not get it. Maybe V3 satellites are not ready yet. So, but again, they did test it with a mass simulator, and this puppy landed. Now you will see that orange streak, that's basically oxidation, most likely because of liquid oxygen being circulated into one heat shield, and that's the point where it's leaking. That heat shield supposed to be actively cooled, it leaked. So that happened. So flight overall, compared to how bad others were, this was like almost returning to last save point. It's like, okay, at least do everything that you're supposed to do. How good or how bad, we'll discuss it later, but at least do everything as you're supposed to. Now let's understand the anomaly that happened. Well, it had one engine booster that went kaput. Now, many people will say that it can handle multiple engine out scenario. Yes, only if it's partially loaded. For example, let's just say you make a Starship and it is supposed to be carrying 100 ton to orbit and it has 100 ton payload. You can't risk that. If you have even one engine failure, best case scenario, all other engines will clock up. So most of the time engines are generally going at like 90% of throttle or 95% throttle. They only throttle down a little bit for max Q and then they go YOLO again. And again, if one engine goes kaput, all engines will throttle up to compensate. But there is a limit to that, especially if you lose 2 engines or 3 engines. So then why they say it can handle it? Well, there are 2 options. Option number one, you just keep going and then you land the rocket. You do not do deployment and all that. You just land it. It's like, okay, let's try it again. That's one option. Second option, you push it and you do not save any propellant for reuse. So payload can be dumped into orbit reliably, but your rocket will not be reused. It's a doable thing. But again, let that be clear. If you could just remove those engines, you would not put engines. We need all engines working all out. You do get a bit more flexibility, a bit more throttle, but you do not. This is not healthy to have a rocket where it's like, oh, we put 33 engine because most of the engine keeps shutting off on its own. That's not good. And it's very rare for them where they have all engines working as expected. Even in this one, they had one engine kaputting. I genuinely hope V3 engines are far more trustworthy. It's one thing to have like, oh, we did 10 missions and one of them had one engine kaputting itself, versus all the time almost 1 or 2 engines kaputting itself. So that's instability. But again, let's hope for V3. And Starship also had a mini boom. Now, this mini boom is very big and looks weird. So some people are saying maybe some orbital debris kaput maybe some boom event, like as in some gases were trapped and it got heated due re-entry and then kaput. I do not know what happened here, but it's huge. Like, let that be clear, it's huge. Thankfully, this space was void space, so nothing major happened. But again, it did boom event. So how the heck that happened? That's not. And flaps also did not work as expected. They were still having like, bleed through, as in like the hot gases started to destroy them, both of them. So that was also, and you can see it was kaput. And again, if you're like, okay, but it still landed, it's a reusable rocket. It cannot risk that. You're not gonna cut that part out and weld it again. So fundamentally, they need V3 at this point in time. This V2, So, and again, that heat shield where they have active cooling leaked, that gave the orange oxidation color on the carbon tiles. And carbon tiles, or it's like the stainless steel, it looks like carbon tiles. So that's what it is there. And they might have 2 V2 rockets still remaining, which they're gonna kaput, which again at this point in time feels like, why? They may already have produced the engines, V2 engines, and they're like, okay, let's do everything V3 with V3 engines. So that may make sense, but so do not expect too much major improvement in next 1 or next 2 launches. So anomaly did happen. So let's understand the overall scope of the program. It is in a problematic state. Let the be clear. It is in a problematic state because it's now causing delay to Artemis. Artemis at this point in time, because again, Artemis is a government project, they do have milestones, so to say. Like at this point in time, you should be, practically speaking, demonstrating propellant transfer from one Starship to another Starship in low Earth orbit. They are nowhere near that. So yeah, that is causing now delay to Artemis. Now, is that a big deal? You could have been a very big deal because again, the early days, because of some back shady dealings, there was only one player in Artemis, and thankfully government fixed that. Now there are 2 players, so there is a very good chance that Jeff Bezos can take care of it. And be mindful, Jeff Bezos' rocket dumped payload into orbit in one go. It does not matter whether it recovered, did landing or not. It did what it's supposed to do. Extra points, bonus point was lost, but it did what it's supposed to. So SpaceX, basically NASA does not care if they launch $2 billion SLS and it dumped payload into moon and the rocket goes kaput after that. Reuse is secondary to rocket. Rocket's first task is dumping stuff into orbits. So fundamentally, Artemis is being delayed and they are nowhere near. Let that be clear. At this point in time, they do not even have anything that resembles anything that would be required for lunar system. They are very far away. It's like, you can talk, but again, he was talking about landing on Mars in 2020. So I do not know how many of you remember that. So fundamentally, he can talk, but right now it's way far out. from Artemis point of view. Now, why the heck a company that is so successful as SpaceX is having this much issue? Well, have you seen certain times a project manager, they end up asking way too many things? Yeah, the desire of utilizing stainless steel is the main problem. This whole system is suffering from that. We used to use stainless steel, like basically V2 rocket and early rockets, but it was like, yeah, no, we switched from that very early on because it's not good. Why it's not good? It can give you 8 grams per cubic centimeter. Now, how heavy or light that is? Well, here's the deal. Falcon 9 utilizes lithium aluminum alloy, that is 2195 series alloys. Those puppies are 2.7. Majority of space runs on that. And if you looked into SpaceX original concept, which was a interplanetary transport system, that was utilizing carbon fiber. Carbon fiber can easily reach below 1.9 grams per cubic centimeter. So fundamentally speaking, it's too goddamn heavy. And that weight has multiple penalties, not just a penalty that it takes too long to go to speed. It has the another penalty, it takes too much energy to decel also. Again, think in this way, when you are making a high speed car, because of inertia, if you give horsepower to the engine, you will have higher velocity at straights. But if you want to make the car fast, you will make it as light as possible. It will accelerate quickly and decelerate quickly. So you always want to a fast thing to be as light as possible. Otherwise, inertia becomes a hassle. So if you go from 8 grams to 2.7 grams, your rocket is like, bro, I got this. That's how Falcon 9 works. And you're like, okay, how the heck it handles re-entry heating? They have a heat shield. It's done. It's solved. Go home. Done. So, and you're like, okay, can it handle orbital re-entry? Space shuttle was made out of aluminum, not even titanium. We good. We got this. So fundamentally speaking, this choice to utilize something cheap, which does give you two benefits. It gives you resilience against heat, which again, you should not face heat if you have heat tiles. It's not like you have naked steel going there. So that's a mute point itself. And second, it's cheap. So that is the primary design constraint that they are dealing with. So what does it mean? It means their V1 was 100% useless. So the V1, this is from Elon Musk himself. I'm not making it. And people knew about this. Like it's Starship, as you look at it, it's 100% useless. So V1 would only do 15 ton to orbit, which they were way too optimistic with that. What does that mean? That simply means Falcon 9 is bitch please. Falcon 9 will say bitch please to Starship V1. And it would be cheaper to use Falcon 9, even without second stage reuse. What about V2? 35 ton. Falcon Heavy will say bitch please. And again, even practically speaking, I do not think they will actually manage to put 35 ton in orbit. So that is there. So what are they doing to solve it? Again, this is a problem, known problem. So what are the solutions? Major solution is just that. Switch the stainless steel. Yes, it will increase the cost, but if your rocket is going kapoom and it has only capacity equivalent of old as Falcon 9 early generation, V1 Falcon 9, it's no point. Heck, this capacity solo India has rocket after that, which is called GSLV Mark 3. So 15 ton is like, no. And they are somehow now claiming that V3 can do 100 ton to orbit. Now, what has changed that can give them this sort of confidence? Well, if you look into the propellant loading, propellant did not change from basically V1 to V2. So they had 3,250 tons to 3,259, exactly the same. However, V3 rockets will have more propellant, as in it will have 3,600, so few hundred tons extra. And thrust will go exponentially more. Thrust will go from 7,100 to 8,240. This is what they are banking on at this point. Basically, if you increase the cylinder height, you get surface area, but volume goes up by cube. So you do have the benefit of actually increasing the surface, and power to weight ratio improves drastically. So that's why V4 is ludicrously long. So they are brute forcing it. And the second point of brute force is hoping that V3 rockets engines are good. Raptor engine V3 is actually good. Now, I do not expect Raptor 3 to be too much in terms of power, but it should be lighter. And if you are talking about 30 engines, that will have a big impact, even if every engine itself is only 1 ton lighter. So that's what they're banking on right now. The long-term solution is change the material. Like, do not get stuck on this freaking stainless steel. Change the material. That will solve all the problems, but it's up to them. So at this point in time, their hope is give a V3 engine, hope it actually has enough oomph to actually do these things, and hope enough propellant you can give to bypass the penalty of stainless steel. And that's why they have to dump the cap, basically hot staging ring. Again, it's too goddamn heavy. And again, that's the whole point. If they try to decel, 3 engines will be like going full out, 105% throttle, and they still will not be slow enough. That's why they have to ditch it. And this time they are designing it with almost like an old school hat design. That hat design is similar to what Soviet Union used to have. And a Gia rocket also had that. So and that is that. So let's see what happens, because if they fail to make it lighter or brute force improve the engine and power to weight ratio, yeah, it's gonna be epic fail. Like fundamentally, that's where the problem is lying. That's why this is problematic fundamentally. Like that's why you are ditching a part in a reusable rocket. It's just too goddamn heavy. 8 gram per cubic centimeter versus 2.7 versus 1.9. Oof. And again, aluminum is not that expensive and they have expertise on it. That's how they built Falcon 9 and they mass produce it. Second stage is use and throw. So they are mass producing it. They're good. They got this. So they can easily switch. So what can we expect in the future? Well, here's the deal. Those problems are known problem. How will they solve it? That's up to them. That's a problem that's done. How the heck they solve it? That would be interesting to watch. They could change material. They could brute force the thing. Right now, it's looking like they're going to brute force it. Or if that did not work, brute forcing did not work, then they have to change the material. So that is there. And this will become the only rocket that has went to orbit 10 times, as in like launched 10 times, and still has not deployed a paid payload or even actual payload. 10 times is a huge. In rocket industry, 10 launches and not able to do anything is like, damn, that's bad. Like the worst from SpaceX point of view was Falcon 1, 4 tries. This puppy is crossing 10. To give you a context, Falcon 9 did what it's supposed to do in one go. And same happened with Space Shuttle also. Same happened with SLS also. Same happened with heck, even this reusable topology with Vulcan. Vulcan also did what it's supposed to do, as in like dump what it's supposed to dump. And then you are talking about Blue Origin's New Shepard, that also dumped payload into orbit. And you're like, okay, did not land, does not matter. Rocket's first job is dump stuff into orbit. If you do not do that, does not matter whether you will land successfully or not, or I have reused this. No point. It's not reusable. Because again, if you're not going into orbit, what's the point? Just yee. So, no point. And time and money is limited, specifically with Artemis contract. And again, Artemis contract is not a single player event anymore. It has dual contractors. So it can be cancelled if they keep just like, okay, we're going to launch it. And let's just say next year also does not perform adequately. And they're like, yeah, it takes too long for them to actually do 15 to 20 refuelings, which I'm genuinely shocked how the heck they are stuck on that. It's like, that's a dumb idea. Just do docking. Like look at China. China is using much smaller rocket to do much bigger things. How? Dock the payloads. Why can't you dock payloads in this? They do not have payload deployment window. How the heck you open it if you have so much heat tiles? It's difficult. It's difficult. And again, that's why Space Shuttle had wings on the bottom side, not in the center. If you have it in the center of a cylinder, opening the payload bay would have become too much hassle. So they have to figure out a way where they can have a giant window and dump things into orbit. 100 ton, one launch, 100 ton, another launch, good, go home. Nothing more than that. One payload, one booster, kick stage, or as you call it. And again, that's how exactly Saturn V did. That's literally what China is doing. It's much more logical, much more simpler, rather than 20 times. So, let's see. And heat tiles need massive redesign. This tile system is not that good. And again, Elon Musk keeps saying that Space Shuttle tiles were not reusable. Tiles were reusable. They had design constraints, so to say. The constraint was that tiles were numbered, as in every single tile was numbered. That's why you will see numbers on them. And these numbers were simply meaning one precise tile made for that precise shape and precise size. So that was a bad design. But tiles did not have an issue. Tiles falling off was not an issue. And yes, they did have an issue, but that was not because of the tile. That's simply because a foam block went and punched a hole into it. So there was never a scenario where tiles malfunctioned. And they have always the scenario where tile malfunctioned. So, and why the heck it's malfunctioning? Because again, the formulation, basically how they are constructed, they are exactly the same, is simply because they have poor design on this. The idea is you're going to use hexagon, cover most of the rocket with hexagons and some edges, basically the edges, those will be similar to this. Cool, awesome. But this was designed by like roughly designed, so to say. Like they have stainless steel in that. Why you have stainless steel there? Why? It can be much lighter aluminum. Like why you have stainless steel and you have so much of it. So even if each of these tile is like you save 1 gram or 2 gram out of it, it will pile up in tons. So this is bad. And again, how they're deploying it is like, it's bad. It will crack. It is bad. So fundamentally, the glue part or glue is done, is tested. And again, we have a miniature space shuttle. It goes to space, stays there in space for hundreds of days, comes back, nobody talks about it. Not a single tile ever falls off. Like, tile is a solved issue. So how the heck SpaceX is having issue? This is the penalty of having too much vertical integration. These things are very niche within a niche with some extra niche. So there is a very good chance they do not have very clever engineer, or Elon Musk just said it. It was like, oh, make it with the stainless steel. It's like this idea of having latches, and they're like, okay, we have to break it in order to remove it. It's like, then why not just use glue? Just like, bro, we got this, we done, we good. First space shuttle that was white color, they tested it and it had basically ties falling off. They fixed the glue, never ever had an issue. Miniature one, still going, never ever had an issue. It's done, it's good, go home. So fundamentally, they are suffering from the penalty of too much vertical integration. They need some expertise and someone who actually listens, actually talks properly. Or because again, this design is stupid. It's falling off every design. This. Even in this re-entry, it's like tiles are falling off. It's like, yeah, there's no point of a reusable rocket when it requires a surgery after that. So fundamentally, they have to fix things. This is not a good thing to say in rocket industry. Oh yeah, we have launched 10 tons. Like, oh, how many tons in orbit? Yeah, 0. It's like, So let's see what happens. Again, place your bet down what they will do in order to achieve this. Because again, if you make it out of aluminum, this puppy out of aluminum, it will decel quickly. That's the core point of it. It will decel very quickly in the basically upper atmosphere, and then you can easily land it. Everything wins. Price goes up, but again, a rocket that goes kaboom is useless. So this was my presentation on a Starship 10th try, so to say. Hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show my extra disappointment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.